So in this follow-up exercise, I'm going to examine the question of happiness, self-reported happiness, on actually a scale of 0 to 5, which actually I mistakenly said 1 to 5 in the previous video. It should be 0 to 5. It doesn't make a difference in terms of the results or the analysis. So what we have here are people who reported their life satisfaction or happiness with life across past, present, and future. And these are people who did not win the lottery. So 22 people provided ratings for their happiness levels in the present, past, and future. And this is important because we want to have some sense of comparison with people who do win the lottery, which I've looked at in the previous example. And you'll recall that the scale looks something like, or the chart looks something like this. So let's check it out for people who did not win the lottery. Maybe it's exactly the same thing. Who knows? So the dependent variable is the same dependent variable. So that goes in as a check mark. It's a 6-point scale. It's ordinal in nature, but that's okay. As I talk about more in the non-parametric statistics chapter, I talk at length about why that's appropriate. If we had less than 5 points, then it would be a bit worrisome. Number of levels is 3. So that means that the protected Fisher's LSD is a possibility with this analysis. And we've also got check normality outliers, so let's do that. Put the 3 variables into the dependent list box. We've done this many times now. Click on Outliers, click on Plots, Histogram, deselect stem and leaf, click OK. And what we're looking for are the skew and kurtosis levels in particular. And skew and kurtosis are less than absolute values of 2 and 9 respectively, so that's good. Again, less than 2 and 9 respectively. And for the future, less than 2 and 9 respectively. So all 3 levels are normally distributed, which you can see here. You can see that nobody's actually responding 0 or 1, which you'll find sometimes in scales. We do have a bit of an outlier situation here in terms of the present. Let's just look at this a little bit more closely. Or is that the future? No, that's the present. So the present has a little bit of unusual outlier situation. I actually don't think this is really accurate because when you look at the data this way, there is no outlier in the data. So again, you'll recall an example in the one-way between subjects ANOVA where it looked like there were outliers. But because the skewness is nowhere near to being problematic, I wouldn't actually follow this up and do anything with it. I actually feel like it's possible that the sample size isn't quite large enough to really evaluate this question seriously. In combination with the skewness levels, I don't feel like there's a problem with these supposed outliers. I suppose the other reason to think is that you can only score from 0 to 6. So in that case, I don't know if it's really realistic to see an outlier. Unless everyone scored 0 and one person scored 6, maybe that would be an outlier. So again, I tend to look at outliers in the context of skewness as well. So I encourage you to do the same. So I'm going to treat these data as sufficiently normally distributed for the purposes of the analysis. So I'll give myself a check mark for that one. Check sphericity, that's going to be done automatically in the ANOVA, so I'll be sure to check Mauchly's test of sphericity. And I'm going to do the protected Fisher's LSD in this analysis. So analyze general linear model repeated measures, 3 levels, and it's time, past, present, and future. And I'm going to put the 3 variables in the within subjects variables box, click on options, put the time variable in display means for, click compare means. Now LSD none, that means no adjustment, and that's fine because I'm going to protect it with the ANOVA part of the analysis. Click descriptors, effect size, click continue, and we'll want to plot the means of course. Put that here and continue, and we're done. So here's the analysis, and we can see that the means are 3.32, 3.82, and 4.14. Again, this is for the people, 22 sample size, for the people who have not won the lottery. And so the pattern of the means is very similar to those who did win the lottery. Mauchly's test of sphericity, not statistically significant. The Hunfeld is very close to 1.0, which again I've mentioned before, indicates that there is no difference within sampling variability, or I should say that the standard error of the difference between the means is roughly equal across all comparisons. That's a good thing. And here is the analysis time, sphericity assumed, an f-value of 10.83, and the p-value significance is less than 0.001, so I've rejected the null hypothesis. Had this p-value been greater than 0.05, I wouldn't have rejected the null hypothesis. So these means, these three means, the null hypothesis of equal means has been rejected. Again, we don't know which comparisons are statistically significant, but we know that at least one comparison will be. Here's partial eta squared, 0.34, so 34% of the variability in people's happiness ratings is accounted for by the time period, excluding the shared variance between the time periods. And we can actually look at those correlations, as I often recommend you to do in the within subjects ANOVA scenario. And here are those correlations. Positive correlations, not as big for present to future, but there are positive correlations here. They're not all statistically significant, but that's the general trend you'd expect. So the null hypothesis has been rejected, and there are positive correlations between the satisfaction ratings or happiness ratings. Let's actually look at the partial eta squared 0.34 for people who have not won the lottery. And for people who won the lottery, the partial eta squared was actually 17.9. So it was actually at least numerically smaller. So that's a bit interesting. Now here's the graph. Let me create this graph on the scale that would be the same as, you know what, it should be 0 to 5 and 0.5. So we're getting that upward trend just like we did for people who won the lottery. And we can see here that if we compare it against the other analysis, which is the people who did win the lottery, it's very similar. I should change this scale to 0 to 5 as well. So look at that, very similar. So at present, the people who won the lottery reported a mean satisfaction or happiness level of 4.0, and people who did not win the lottery reported a mean of 3.81. So numerically, the people who won the lottery did have a higher satisfaction or happiness level, but we don't know if that's statistically significantly different. We'd actually have to do a different type of analysis, which I actually do cover in another chapter on the combination of within and between subjects design. So I encourage you to check out the mixed design ANOVA chapter to follow up this story. I guess the last thing I'll mention is that the contrast analysis is statistically significant. There's a linear contrast analysis that is statistically significant going upward. Now, in terms of individual comparisons between past and present, it is the difference in the means, 3.3 versus 3.8, is statistically significant. And the difference between the past and the future is also statistically significant. So that's 3.3 versus 4.1. The last comparison, which is present to future, 2 versus 3, is not statistically significant. So in this ANOVA, as a summary, we've rejected the null hypothesis of equal means. There is a trend leading from past to future that is statistically significant based on the contrast analysis. Now, if you wanted to, you could follow up with the paired comparisons. Because we've got a significant ANOVA, we can look at the Fisher's LSD comparisons, and we've got 2 of those comparisons that are statistically significant. Past and present difference, and past versus future significantly different. There's no difference that's statistically significant between present and future. So again, ideally we could combine both of these analyses, the first one with the winners and the second one without the winners, so that we can actually make comparisons between the 2 groups. And again, I encourage you to check out the chapter relevant to mixed design ANOVA to uncover the ultimate answer to this question.